Welcome to the lecture series of power electronics. In this video, I am going to discuss the design of step-down chopper, that is design of buck converter using MATLAB. So I'm going to explain the code. Based on the code, you can get the waveforms corresponding to the particular buck converter. So let's see how to get started. Before explaining the code, let me explain the four important steps. The step number one, setting of parameters. Here, input voltage, output voltage, switching frequency, the value of resistance, then inductor value, capacitance value, and the duty cycle based upon the like a PWM signal. So you can compute it by used on you already know that V out by V in is equal to duty cycle of buck converter or a step down chopper. So setting of the parameter is the first step for designing the MATLAB. So the second step is you are supposed to set the time parameters. T is nothing but the total time period. Okay, because it comprises of on period as well as off period. Later on, you are supposed to set this total simulation time, set the twice the switching period or to observe the waveform. You should know the relation between the time period and frequency. Similarly, dt is the time step for the simulation. You need to remember that set 1 by 100 of the switching period. So these are the three segments which are comes under setting of time parameters. Moving on to the third step. In the third step, you are supposed to make the simulation loop. Simulation loop in the sense that the loop simulates the behavior of the buck converter over a time, because we should get a waveforms corresponding to the buck converter. So you need to take care about inductor voltage, which is calculated based on the switch position. The second thing is you need to compute the inductor current. You can use the Euler's method. By using the Euler's method, you can compute the value of inductor current. Similarly, the output voltage and inductor currents are recorded for each and every step. These are the basic step which are comes under the simulation loops. Okay, you can easily use the for loop. Similarly, plotting, you can go for the subplotting. So plot command will be used. The input voltage, output voltage, and inductor current waveforms are plotted based on the subplots. You should know how to plot the subplot. I'll be showing you that. These are the basic important steps you should know, like how to plot the a particular converter. So moving on to the discussion, I am going to write the code first. Later on, let me run the program and display the output. So first of all, you should know that buck converter, the average output voltage is less than the input voltage, and you can see the intercurrent, but it will happen during on and off. Those parameters you have to take care in your mind. Now let's get started. Okay, I'll be opening the MATLAB first. Go to the editor file of your MATLAB. Let me type the program. So I have typed the program. Yes. So here the steps are clearly written. First parameter, setting of parameters of buck converter. You can decide the parameters, what are all the parameters which are required. Give the convenient name. Set the variable name for your convenience. Remember, anytime you need to call the variable, so it should be in a convenient fashion. Second one is called the time parameters. You know, like the t, sim time, everything you have to multiple consider. Okay. DT will be like I mentioned about one by hundredth of the total time period that you are supposed to mention. Time step for the simulation. Similarly, pre-allocate the arrays for storing the results. Here you need to mention the time V out you are supposed to mention. Similarly, V in also you are supposed to mention. Then initialize the variable. Later you are supposed to create the simulation loop. For loop will be used here. Okay. Now you need to calculate the value of VL. Then similarly, IL will be done using the Euler's method. You can compute the value of IL. It is very clearly written over there. That means the simulation loop, creation of the simulation loop till here. Now later I'll be showing you the plotting of the waveforms. Here you can use like a subplot. See, subplot you can see 3, 1, 1. Okay, based on the rows and column that is going to be printed. How many plot will be there? Like three plots you are supposed to make out. In that, the first column and row will be directly specified. The title, labeling, grid, that will give the appearance of the lab. If you want, you can give the labeling of legend also you can give if necessary. Likewise, you have to plot the 3 graphs are required. Okay. So now you have to save the program. Okay, let me save the program. I'm going to save. Yeah. So you can give the name of the given program. I'm going to give buck converter or step down chopper. Step down. Let me save in the desktop. Don't forget to give the proper path. Path you are supposed to give. Yes. Later on, you are supposed to run the program. I want to run the given program. Okay. So let me run the program. Okay. So you need to give add to path. Okay, you are supposed to give add to path. Please do remember. Okay, please do remember add to path should be given. So later on, your program will be run. Now we'll be getting the output. Now let us see how the output will be displayed. So based on the output, you can analyze very easily. Okay, yeah, I'm waiting for the output. Let it be run. Okay, yeah. Now let me share the screen. I'll be showing you the output waveforms. Okay, now you can check it out. The given buck converter, the input voltage is how much? 12 volt, right? 12 volt. You can check the input voltage of 12 volt. Okay, input voltage of like 24 volt. See here, 24 volt. So DC voltage only. So these things and all you will be setting up to right. Then voltage, output voltage, that will be 12 volt because the step down action will be taken place. And now the inductor current during on cycle, then this is during off cycle, on and off cycle. Okay, on cycle and off during off. What is going to happen for inductor current? I1 plus I2 by 2. That will be the average inductor current. So here we have chosen like a continuous, like a discontinuous conduction mode. That means inductor current goes to zero only. Every cases you can see like inductor current goes zero. This is a discontinuous mode of operation. So these are the fundamentals you can observe from the waveforms. Still, so many parameters can be drawn if you want to modify this particular program. So we can make out the modification. Okay. So in this session, what we have discussed is we have discussed about how to write the code or how to design the step-down chopper using the MATLAB. So I explained various steps such as parameter settings, time parameters, later simulation loop, afterwards the plotting. So we'll be plotting the subplots. Okay, that means three graph I could plot in a single graph. So that's what exactly we are performing. So if you have any queries, kindly put up in the comment box. I'm happy to answer. So if you want, you can note down this program and try it out using your MATLAB. So don't worry that you have licensed one. You can go for like a basic version. Then definitely you can run. Online versions are available. Go to MathWork and you can access the online MATLAB. I have already done the video. If you want, you can go through that prepared video already, which is already uploaded very long back. It's available in the playlist of MATLAB. You can check it up once. So thank you very much for watching this video. Happy learning. Have a great day. Thank you.